So yeah, it's great that you guys all made it. This is the 22nd weekly dev call for Matchbox. Hey Guilty, nice to see you. And on this call, we're updating the community on a few different projects and things that have been happening and going on. And yeah, today we have 3 items on the agenda, and we have Francesco with Apibara. He's going to talk about that and present it because it's like a super useful tool. We have a small update on the .NET SDK by Tom Rocks. Still progressing on that. Very good job. And then we have a presentation of a new library, Graphero, which is not actually a project that Matchbox supports financially, but which is, I think, something very interesting to look at, which maybe a few people might be unaware about. Luca is not here yet. I'm gonna ping him just to make sure he's not forgetting. But I think we can start. I think we can start with the Apibara walkthrough and presentation. Francesco, if you're ready.
Yeah, let me share my screen. Do you see it?
Yeah, I can see it.
Okay, perfect. So yeah, basically Apibara is like a way to build application by composing different streams of real-time events from both like on-chain and off-chain data. So yeah, like I assume most of you are developers, like you are in the dev code and everything. So your application probably looks like something like this, right? You have your smart contracts on StarkNet, and then you have a front end, hopefully in React. So you use the StarkNet React library I wrote. And then, maybe you update it to use the JSON RPC endpoints. So every time you want to get values, you make a StarkNet code. The reality is that you have a lot of data in your application, so you start making a lot of StarkNet codes. And then obviously your application grows. Maybe it's a game, has a lot of data, and so you start making a lot of StarkNet codes. And then your game becomes like a production-ready game, and now your front end is basically making too many requests, right? And that's not fine. That's actually everything is on fire. Your JSON RPC nodes are on fire, or you're giving a lot of money to Infura. So maybe there's something easier way to get data from the chain. And it is that with something like Apibara, which is basically an indexer, you get on-chain events, and you can compute the state and store it in a database. And after that, you just make one API call, or like anyway, a few API calls, and you always get fresh data to display in your front end, or like it could be a mobile app. And you probably see me make StarkNet calls, right? But there are very few. There are very few of them, only for data that can be actually fetched very easily from the chain. And so, as I mentioned, Apibara is basically, at this stage, it's basically an indexer. It means that on the smart contract side, so on StarkNet, you emit events. In this case, I think that contract is from solve to mint 2. In this case, someone solve like a puzzle. And so the smart contract emits an event to signal that, and then the indexer detects that this event was emitted, right? And they just run a piece of Python code where, for example, in this case, they will update the number of puzzle that particular user solved, and that's the the info.storage, basically where it finds the previous value, and there it says, oh, I want to find the previous number of puzzles solved by that user and increment that number by 1. And then maybe we want to send a message on distro, just say, oh, this user solved the puzzle, like congratulations. And we can do that, so which is pretty cool, I think. And so if you want to have like a high level overview of what is Apibara, it's basically like a layer in between the blockchain, like the off-chain data that comes from other sources, and your application. And this is a way to organize and make sense of all of this data. And especially when there's like a blockchain reorganization, that we will see later, or when you want to upgrade your application. So a few of use cases that that come to mind, and especially I know that I discussed them with some developers, some of them in Discord, is that big use case, especially for Matchbox, is games. So games have a lot of data, and basically you cannot really fetch the data from the smart contract directly, because that will make the application very slow. And so it's a good way to sort of cache these events in Apibara and compute the state when an event is emitted, right? So that you can get the data in a format that's already very, say, convenient for the front-end application for the game. Another use case is that social apps, there may be gated content that's off-chain, and obviously it cannot be on-chain, otherwise everyone has access to that gated content. So maybe you want to only store the hash of the content on-chain, but keep the content off-chain. And with something like Apibara, you can join the two of them so that you can only show gated content to users that are logged in and they have access because maybe they own a specific NFT or maybe they verified their Discord account. And you can keep the data hidden from other users that don't have access. And for DeFi, once there are enough DEXs on Starknet, right, or like on other chains, it makes sense to be able to compute the optimal path to convert between two different tokens. And obviously that operation is very, very expensive and requires to run some heuristics, so it's not even like a known algorithm find the best one in a limited amount of time. And so we can compute this type of path off chain and display it to users. And because the logic to do the execution is still on chain, the user doesn't need to really trust our results. And so how to get started with Apibara? I provide like a nice template on GitHub, like under the Apibara organization. And it is that you can click on the green button that says use this template, and you create a new repository with all the files already in place. And that basically is this repository basically contains like a Python project that's already configured so that you can run your indexer very easily with what I think are the current best practices for using Apibara. So before we start, you need to have Docker installed and then basically run this command, which is the docker compose app. And this command, what it does is that it downloads a Docker image of MongoDB, which is the database that's used by Apibara currently. And also it downloads the Apibara image and it runs it on your machine. So you don't really need to configure anything. Everything is already done for you and runs locally on your machine. Also, probably it's time to mention that Apibara is completely open source, so you can look at the code, you can change it, you can improve it, you can fix bugs if they really bother you, and you can run it on your machine, right? It's not like a centralized server. Okay, so after that, you can start looking in the indexer.py file, and you can see more about how Apibara works. So we start by defining what is called like a runner, which basically is a way to configure the way you will run the application. Right? So the indexer. In this case, I want to specify the network, which has used the Starknet early testnet. Obviously, there are more networks, and you can add as many as you want. And in this case, I also give like a unique indexer ID because I can run different indexers sharing data in the same database. So for example, if I want to index saying that if I build an application that requires some bridging between layer 1 and Starknet, right, I can run an indexer for the layer 1, so for like Ethereum, and I can run an indexer for Starknet, and so that the data can be sort of joined, and I can have queries that work on both type of data. And then basically I add up, basically like what is called like a block handler, which is simply a piece of code that is called every time there's a new Starknet block. That's mostly used like if you need to do any type of, I don't know, like aggregation, or you want to pre-compute some data or report some progress. You can just hook into that hook. And then finally we get to define what type of events we want to index. We use basically what is called like a filter, and we filter by event. In this case, we want to see all transfer events from the brick contract, right? And in this case, we just want to index from block 201,000, just to split up a bit the first use case. Maybe we can start from block 0 if we wanted. And then finally, this last line, it's actually running the indexer. So the way the indexer works is that it gets events from the Apibara server, and the Apibara server keeps track of which blocks were indexed and which blocks have not been indexed yet. And it will also send information about new blocks or like chain reorganizations, all those like low-level details that actually as an application developer you don't really want to care about, but it's still important to know about. And so that's basically an event handler. Is super simple. It just gets a block of like all events grouped together by block, so you can even compute like block level like statistics. And in this case, we go through each of these blocks, we just convert them to a dictionary, and then we store it into the MongoDB database for like in what I call the chain-aware database document storage. And basically, the cool thing is that everything is super simple. So you don't need to, like download another executable and run it on your application. You just do Python and then the name of your script, and it just runs. Right. So it's very easy to iterate during development. You just Ctrl+C, you stop the script, and then you can restart the script. And by specifying a different flag, you can restart from the beginning or from where it left off. So again, I think the development life cycle is quite fast and it's quite enjoyable. So as I mentioned, one of the cool things about Apibara is that we provide this chain-aware document storage. So what is document storage? It's basically a way, instead of storing data in a, say, table, like we would do like in a relational database, we just store basically JSON objects, and then we can filter them based on attributes, or we can sort them, we can transform this data. So the trade-off is that it's very expensive to have relationship between different documents. But the advantage is it's very easy to insert data or to like upgrade and change schema, because it's sort of like schemaless. So you can put any type of document into document storage. Why chain-aware? So the main issue with indexing and blockchain data is that there can be chain reorganizations. So that's, for example, I think it's easier to understand with an example. In this case, we have block 10 at the top. The current bid and ask is like 120 and 130. Then a user submits the order. And so we, between block 10 and 11. And so at the end of block 11, we have the new ask price is 1.25. But after a while, we have a chain reorganization. It means that the miners, or like whoever proposed the block, right, decide to start their chain not on the previous head of 11, but on a new head of 11, and then they propose block 12. That happens actually very frequently. And so now the order that was previously included in the old block 11 is not there anymore. And so the ask price is not 1.25, it's 1.30, which was the value that was previously at block 10. And so if we simply update the values every time we get an event, we cannot really roll back data, right? And so we need a way to sort of take a snapshot or something like that between blocks. So if we have a chain reorganization, we can roll back to a previous value. And so the way to do that is with temporal databases, right? The Wikipedia page is actually quite nice about that, right? So let's say at block 10, we receive the order, and we store the bid and the ask price for whatever we are trading. But now we also add a piece of metadata, and we add when is this entry valid, right? And we know that this entry is valid from block 10 to whoever block, basically it's valid from block 10 to the end of time, basically. And then on the first block 11, we see we want to update the value. And so instead of updating the value, we update the old value, and we say that it's valid from block 10 to block 11, and is inclusive of block 10, but is exclusive of block 11. So it's all blocks from 10 included to 11 not included. And then we add a new entry, which is the updated value. And here it should have been like the ask price to be 1.25, not 1.30. And we just say, OK, this value is valid from block 11. And so now every time we want to fetch the most recent value, we specify the previous filters that we used, and we add a filter that says valid to, and valid to has to be like null. So it means there's valid, it's the most recent value. And also what's cool is that we can see for each document, we can see the historical values, right? And so we could even plot it on a plot to see all values and the previous values over time. So when the chain reorganization happens, what we do is that we delete all values that are valid from a block that was like invalidated. So in this case, we delete all values that are valid from block that is greater than 10. And so we delete the most recent entry, and then we update all entries that have the value that was valid up to block 11, non-inclusive, and we remove that validity because now that's the most recent data after the invalidation. Now we apply the new block 11, and in this case, there was no trade, so we don't need to update the old value. And we keep doing that. And now the most recent value sort of roll back to what is the real value after that. And so if this sounds complex, it's kind of easy, it requires to a bit of thinking about it, right? But the good thing is that Apibara just provides like a document storage service. You just insert data, update data, and then Apibara will handle all these low-level details, obviously implementing a temporal database on top of MongoDB, which is very, very nice to use in this blockchain context. So now I explained what Apibara does now, and I want to also share with the MetSports what we are going to do in the next 6 months by the end of the year, basically, is that we want to our vision is that about composable Web3 streams. And the idea is that, let's say I'm building a game and I want to get data from, say, an exchange about the exchange rate of my token, and I want to get data from NFT marketplaces. And so our vision is that people will be like streams of, say, all NFT trades or all NFT offers, right? And publish it. And there will also streams about token prices. And then you, as a game developer, can combine these streams together with the data from your game to be basically one stream that is specific for your game. And then you can publish this data to your front end through WebSockets. So you have real-time events happening in the browser. So it's very nice user experience. Or you can publish a new stream that is specific, again, for your game. And people that are building maybe game analytics, like this platform where you can see all statistics about different games, can integrate your stream to build their application. And then the idea is that obviously a lot of you now are working with other people on projects, right? And I think Apibara should make it very easy to collaborate on basically the backend for your game. And so we want to have a user experience that's sort of like Vercel, in that you can open a pull request on your repository, and we will create a temporary deployment of your application that is only for that branch. And you can preview it, and you can integrate it, say, with your staging environment in your front end. You can make sure everything is working. And once you click merge, then we will actually upgrade the production environment. That way, also, you are confident that when you are deploying, you're actually deploying something that works. And so hopefully you will be able to deploy much more frequently, because it's a lot less work. You don't have to think about deployments anymore. And so finally, to keep updated, you can start a GitHub repository with the open source code for Apibara, or follow us on Twitter. You can also follow my account on Twitter. Here is the links. I mean, they're not technically links, but you get the idea. Yep, that was it.
All right, thank you so much. That was great. Do we have any questions for Francesco and Apibara?
Hopefully it's because everything was very clear and not because I bored you.
I got a question. I think you've already talking to Darkus or Chris about Apibara, but are you who you store all of this indefinitely? What's the or let's say Influence wants to utilize this at some point, and we run an instance of it. Is all of this stored indefinitely, or how exactly does it work? Because I mean, it's extremely helpful to be able to roll back asks and bids for obvious reasons in games, but once you start doing that, you kind of have to do it forever.
Yeah, so the good news is that chain reorganization happened, but usually you roll back by a few minutes, right? You don't, there's not, so far there hasn't been a chain reorganization that the chain went back to a state from 10 hours ago, right? That would be very, very bad. And so you could have some sort of we could add to Apibara some sort of way to actually invalidate data that actually bursts data that is older than some threshold, like maybe 1 hour or 10 hours. So that way your database size stays reasonable, but also you don't actually, you are not worried about chain reorganization that go further than that.
Perfect. Okay, that makes sense.
Any other questions for Apibara and Francesco? In case you have questions later, or you didn't get everything, this is obviously recorded as well, right? So this is gonna land on the YouTube after the after the call is over, so you can take another look and watch it at your own time again, just in case you want to do that. If there are no other questions, then we can move on to Tomrocks and v.NET SDK, and I'd be very excited to hear about your progress there.
Yep. All right. I'll also share my screen. So since last time, maybe some of you guys remember, my goal was to update my library, my SDK, to be able to send transactions or invoke functions in this case. And I've figured out some of what I need to make this work. So some of you may recognize this is the payload that we need to send to the gateway so we can invoke functions. So you pass the type, you pass the contract address, which will execute the contract, the selector for the contract, the call data, signature, and the fees. Now, the problem I have is with the signature and the call data. I haven't really went deep into the call data. It could be the easier part because I have the ABIs of the contract, but yeah, that's still some stuff I'm trying to figure out. How is this really working? How should I build my call data array based on the ABI I have and based on the inputs from my user? So my user will want to use some certain function. He'll pass the parameters, and I have to build that array. And from there is also the signature part, which I was expecting to not be so complex, but it isn't actually so easy for me. So how I understand is that to create the signatures, I just quickly to remember it before I forget, but all my research I was doing it through that StarkNet Python library or package that someone mentioned a few weeks ago. It was well more documented, and the code is way cleaner, way easier to read, and that allowed me to figure out a bit how the invoke functions works. And so what I noticed from their code, to create those signatures, what they do is they first hash the whole array of call data, and then they hash the whole payload, and from there, with the private key and that hash, they manage to generate those signatures through elliptic curve signing, right? But yeah, I'm still struggling a bit with that hashing signing part. Not sure if I have out of the box stuff for it in .NET, or if I'll have to implement some of those algorithms from scratch. If I have to, it will be quite a big learning curve. But yeah, that's what I'm trying to figure out next. Make sure I can sign and build the call data from my code. Right now, like you see, I have built this all manually. So I used other libraries to generate the signatures and the call data. But I can use mine to send it. I can show you the transaction being sent on the test network. So we see the response, transaction received, and it gives you the hash. So it will take some time before it appears on the Voyager, but during that time, I'll just show you the logic of my add transaction, which it's really simple. So I build a path with the base URL of the test network, the gateway URL, and the path to add transactions. I create a payload from my JSON I just showed you, and yeah, I just basically send the content and receive back the response. If we quickly go check if my invocation is already there, not yet, but yeah, those are some that I did earlier for some testing through my SDK, through my library in .NET, and yeah, we see they go through, and yeah, slow progress. Right now I'm getting into that hashing and signing stuff, lots of maths to figure out and to understand. But yeah, maybe some of you guys have some knowledge of some libraries in .NET that already could do that part for me. I know we discussed about Ethereum in the past, which is an SDK for Ethereum. Maybe there is some logic I can grab from there. But yeah, that's current status for the .NET SDK.
Cool. Thank you so much for updating us. On that note, have you talked to the senior .NET developer again? Are you still in contact with him?
So I didn't have any more news from him. He was saying he'll be building some of the base of the unit testing, the integration testing, but didn't hear back. But I don't mind reaching out to him, trying to see if he's still interested in helping.
Sure, yeah, I'm not even talking about like him building stuff, but just giving you general advice on some of the things you've been talking about. I think that could
Okay.
be super helpful as well. Yeah, like, is there anyone here who has like experience with .NET and Unity, and or maybe knows someone who could who you could connect to Tomrocks? Any connections that we could make on that front? Does anyone have like any idea or know anyone who is like?
Yeah, I'll give it a shot for a .NET developer. I mean, I'm very familiar with Unity and C#, but this is a bit out of my pay grade. So, but I know some guys who might be able to help. I'm gonna send an email today and I'll get back to you.
Cool, awesome, that's great. Yeah, that's awesome. Thank you, Mist. All right, then let's try to connect you with these guys, Tomrocks, and we'll see if they can, help you out a bit on that front.
All right, thanks.
You're welcome. All right, that's awesome. Do we have any questions for Tomrocks and the .NET SDK? All right. So usually we would have another point on the agenda, the Graph Hero graph library, which I think is very interesting, and it's something that may not be on many people's radars right now. It's built by Luca Dono, who participated in the Matchbox hackathon. He's been, he submitted the Axelrod Prisoner's Dilemma tournament together with Dirk. And he built Graph Hero like on the side, and it's like a graph library, right, that you can use for different use cases. Like, for example, reputation systems usually involve some kind of graphs. So I think that could be super interesting. So I invited him onto the dev call to raise the awareness of what he's built. But it seems like he couldn't make it to today's call, or he forgot or something. I pinged him and he didn't respond, unfortunately. So I apologize for that, but maybe we can get him on next week or sometime soon. On that note, we don't have anything else. If there's anyone who wants to say anything or ask anything, then now is the time to kind of shout over me.
Swag, I know I pinged you yesterday about the thing going on in Influence. Would this be an okay time to just briefly mention it?
Yeah, sure. If you want to go for it right now, go for it.
Yeah, for anyone building anything that's going to apply to games broadly, or more specifically, could be utilized by Influence. We have something called the Adalian. Oh, sorry. My girlfriend was in a meeting and I realized I'm noise canceling headphones, so I didn't realize. But she left the room. So yeah, I have an Adalian Creators program where you can submit projects monthly, and we basically, as a community, vote on our favorite projects. So if you guys want to participate in, just join the Influence Discord, check out our wiki, and you can go ahead and submit. So that's it for me.
Okay, cool. Short and sweet. That's awesome. Yeah, for sure. If you're interested, check out the Influence Discord and participate. I think we're always happy to support any builders in the whole ecosystem. So you're welcome to do that. And thank you, Ifaway, for taking the initiative on this. But yeah, that's it. I don't have anything else. If you guys don't have anything else, then we can call it a day. And hopefully we'll get Graph Hero and Dono next week on. So yeah, have a great day, guys, and thanks for tuning in.